Welcome to This Explainer. Today, we're going on a really fascinating journey to uncover the gritty, survival-based origins of human knowledge. We often think of science as this modern invention, but we're going to completely flip that idea on its head. We'll be looking at this through the lens of Abdelazim Anis's incredible book, Science and Civilization. And as you'll see, the earliest scientific breakthroughs weren't made by guys in white lab coats, but by our ancient ancestors fighting tooth and nail just to stay alive. So, did science actually exist before civilization? It's a great question, isn't it? Hooking right into our main theme, we have to challenge a very common misconception, the idea that science requires modern laboratories, complex equations, or classical philosophers walking around in togas. What if I told you that the actual foundations of science were laid tens of thousands of years before the very first city was ever built? Okay, let's dive into this. Here is our chronological time travel roadmap. First, we'll cover the myth of pure science, followed by Stone Age fire, the agricultural revolution, the Bronze Age state, and finally, numbers and stars. Starting with Section 1, the myth of pure science and why we need to bust the Greek miracle. And this brilliantly illustrates how the Greek miracle is largely a historical myth. Don't get me wrong, classical Greek thinkers were absolutely brilliant, but they definitely didn't invent science out of thin air. They actually inherited an enormous wealth of practical and technical knowledge from much, much older civilizations in the ancient river valleys of the Nile, the Euphrates, and the Indus. Science started way earlier. I absolutely love this quote by historian Benjamin Farrington. He says that science arises through contact with things, that its true source is experience, and its ultimate test is practical success. I mean, that perfectly captures the reality of ancient history. Science was born not from abstract pondering in some quiet room, but from the urgent, dirty, everyday economic and survival needs of early humanity. Which brings us to Section 2, Stone Age survival and fire, or as I like to call them, our first chemists. Looking at this visual roadmap of historical eras, from the Paleolithic around 10,000 BC through the Neolithic all the way to the Bronze and Iron Ages, it's wild to think they are literally defined by the dominant tools and materials of their time, as observed by historians like J.D. Bernal and Gordon Childe. The evolution of human history is, at its core, the evolution of our tools. In that earliest, harshest era, the most monumental breakthrough was, without a doubt, the discovery of fire. Now, this wasn't just a neat trick to stay warm. It was humanity's very first major foray into applied chemistry, way before safety goggles were a thing. It fundamentally altered our existence. It allowed us to cook food, survive freezing climates, and properly skin animals to make clothing. Crucially, huddling around that fire created the very first social, matriarchal clan structures, sometimes known as totemic tribes. Fire literally built our first societies. But what happened when early humans faced challenges that their primitive tools just couldn't fix? When they couldn't guarantee a successful hunt or predict the rain, they turned to what historians call sympathetic magic. They used rituals and dances as a desperate attempt to control an incredibly terrifying natural world. It wasn't merely superstition, you see. It was a primitive, early form of science, an attempt to find a mechanism to survive when their technical knowledge fell short. Let's move into Section 3. The agricultural revolution. Villages and high temperatures. Now, what's really interesting about this slide is the stark contrast. We jump from the nomadic hunting and gathering of the Paleolithic directly into the Neolithic agricultural revolution. Suddenly, we are seeing permanent settlements, the farming of grains, and the domestication of animals. It's a total ground-up revolution in human socioeconomic existence. And, as you'd guess, with settling down came entirely new domestic needs. To store their grain, they needed pottery. To eat that grain, they needed bread. This basic need led straight to the invention of high-temperature ovens. Without even realizing it, just by trying to feed themselves and store their harvest, these newly settled villagers accidentally birthed complex thermal engineering and applied thermal science. On to Section 4, the Bronze Age and the State, where we start administering the surplus. This creates such a brilliant cause and effect chain. Better farming creates an agricultural surplus. Suddenly, you have enough food that not everyone has to be out in the fields farming all day, which creates a non-farming ruling class of priests and kings. But here's the catch. This new wealth and land requires management, and to administer it, the state literally forces the invention of writing and arithmetic. Math didn't come from philosophers gazing at the sky, it came from accountants desperately trying to track cows and grain. This dynamic created the first major class division in human history. The working class was tied down to manual labor, physical craftsmanship, and farming. Meanwhile, the ruling class was completely freed from that manual labor. And it was this free time that allowed the elite to write down, formalize, and study what became known as the noble sciences, things like advanced abstract math and astronomy. Wrapping up our journey with Section 5, Needs Drive Numbers and Stars. It's all about practical problem solving. So the crucial point is that none of these abstract sciences were invented just for fun. Fractions, they were invented because boat builders needed absolutely exact measurements for their timber. Astronomy wasn't just romantic stargazing, it was required to build a solar calendar so farmers could predict the flooding of the Nile. And geometry? It was a direct socioeconomic requirement for calculating land borders after those floods, and for engineering massive structures like the pyramids. Abstract science is directly, literally linked to gritty physical labor. Taking a look back at our sourcebook, Science and Civilization by Abdel Azim Anis, he highlights a stunning example of this, the Egyptian invention of the 365-day solar calendar. This incredible feat of science was purely an economic necessity. The old lunar calendar just wasn't accurate enough for agriculture. They needed to predict the Nile's floods with absolute pinpoint precision to prevent mass starvation. To do this, they looked to the heavens. They figured out that the stars Sirius perfectly aligned with the start of the Egyptian agricultural year. Again, they weren't studying the stars for astrology. They were using the sky as a giant cosmic clock to guarantee their harvest and keep their society alive. Let's move to and see how this builds. Because of their precise observations of the stars for farming, the ancient Egyptians gave us the 365 days solar calendar. It is a direct descendant of those ancient survival tactics. It was refined later by Julius Caesar and Pope Gregory, sure, but it is the exact same calendar you and I still use today. Mind-blowing, right? But honestly, none of this knowledge would have survived without one key invention. As historian Gordon Childe notes, the invention of writing allowed man to immortalize his experience and transfer it directly to his contemporaries who live far from him and to generations not yet born. Recording these survival techniques, the math, the astronomy, the agriculture, that was the true revolution that built our modern world. Which leaves us with a pretty fascinating thought to wrap up this explainer. We've seen clearly that ancient science didn't just happen in a vacuum. It was intensely driven by raw survival, by agriculture, and by the economic needs of the ruling class to manage their wealth. So looking at our own era, we have to ask ourselves, what hidden economic forces and survival needs are driving the massive scientific discoveries of today? It's definitely something to think about next time you look at a brand new piece of technology. Thanks so much for joining me on this deep dive, and keep questioning the world around you. Okay, welcome to this explainer. We're going to completely reframe how you think about the birth of human knowledge today. When you hear the word science, you probably picture modern laboratories, massive telescopes, or maybe a solitary genius having a sudden eureka moment. But to find the real roots of scientific thought, we actually need to go back thousands of years to the ancient river valleys of Egypt and Mesopotamia. And we need to look not at philosophers, but at administrators. Ask yourself this fundamental question. Why did humans actually invent math and writing in the first place? I mean, you might picture ancient thinkers gazing up at the stars or crafting these beautiful poems to record their myths. But the true catalyst was a lot more practical, a lot less romantic, and honestly, incredibly relatable to our modern lives. The real answer? To collect taxes and count sheep. Seriously. The grand origins of science began, quite simply, because ancient people needed a reliable way to manage their massive agricultural economies. The spark of human genius wasn't born out of abstract pondering. It came from sheer, overwhelming administrative necessity. So today, we're covering 6 main topics: the economics of early science, how writing was basically the first spreadsheet, the birth of mathematics, Egypt's decimal system, Babylon's base 60 breakthrough, and finally, the lasting legacy of all this ancient math. Let's dive right into Section 1, the economics of early science, and how temples acted as ancient corporations. It's so easy to look at majestic ancient temples and just view them strictly as spiritual centers. But in reality, they were the absolute epicenters of ancient economies. The priests and scribes inside weren't just praying all day. They were managing immense agricultural wealth, distributing loans, collecting taxes, and organizing sprawling trade networks. They were essentially the CEOs and chief accountants of the ancient world. To really give you a sense of scale here, check out this staggering number. The Harris Papyrus, which is a famous ancient Egyptian document, records that under Pharaoh Ramses III, a single temple complex owned this jaw-dropping number of cattle, 490,386, plus over 1 million fidans of land. You just simply cannot manage that level of wealth relying solely on human memory. Which brings us naturally to Section 2, writing, or what was essentially the world's first spreadsheet. So, with wealth that massive, priests desperately needed a system. Writing actually evolved in very logical, practical steps to solve this. It definitely didn't start as literature. Step 1 was just using physical signs on sticks for simple tallying. But as the temple economies exploded in size, that wasn't cutting it anymore. So in Step 2, they started drawing simple pictograms on clay tablets, like a quick sketch of a cow or a basket of grain. Finally, in Step 3, as transactions got way more complex, these pictures morphed into abstract phonetic and symbolic representations. Writing evolved step by step, strictly as an administrative tool to log incoming grain and outgoing cattle, way before it was ever used for history or poetry. So the absolutely crucial point here is that writing was basically the original spreadsheet. This invention allowed for the standardization of weights and measures, making massive, large-scale trade possible. And maybe more importantly, it created an entirely new specialized social class, the scribes. This was a massive shift, right? It forever separated the intellectual work of the elite scribes inside the temples from the manual labor of the farmers out in the fields. Knowledge officially became a profession. Okay, moving on to Section 3, the birth of mathematics. Because just writing down numbers wasn't enough anymore. They had to actually manipulate those numbers and calculate things. Ancient civilizations hit a massive wall that historians actually call the problem of large numbers. This is the point where basic counting tools completely failed to manage complex, large-scale economic and architectural data. Think about it. When you have to build giant silos to store an entire nation's grain supply or dig massive irrigation canals to feed cities, guessing simply does not work. You can't just eyeball the volume of a massive cylinder. You need precise geometry and volume calculations just to survive. Let's see how different cultures tackled this, starting with Section 4, Egypt's decimal system. The Egyptians came up with a mathematical system that's actually very similar to the base 10 decimal system we use today. They had specific hieroglyphic symbols for 1, 10, 100, and 1,000. But there was a major catch. They didn't have place values. That means to write a number like 879, you couldn't just write down 3 digits. You had to physically draw 8 symbols for 100, 7 symbols for 10, and 9 symbols for 1. That is 24 individual symbols just to write down one single number. It was incredibly repetitive. And to complicate things further, Egyptian mathematics struggles heavily with complex fractions. Because they mostly limited themselves to fractions with a numerator of 1, like a half, a fourth, or an eighth, with a rare exception of 2/3, their progress in abstract mathematics eventually hit a ceiling. To write a fraction like 5/8, they had to break it down and literally write it as 1/2 plus 1/8. This clunky notation made advanced algebra nearly impossible. It was super practical for their daily building and taxing needs, but it just lacked theoretical flexibility. Meanwhile, over in Mesopotamia, they had a totally different idea. Section 5, Babylon's Base 60 breakthrough. When you compare the two empires side by side, the difference is just wild. While Egypt used those repetitive symbols, Babylon developed a positional base 60 or sexagesimal system. Positional is the absolute magic word here. It meant the placement of a symbol changed its overall value. Exactly like how our modern math works, where a 1 can mean 1, 10, or 100 depending on where it sits. This structural shift allowed the Babylonians to perform much faster, way more advanced calculations. Driven by their sprawling trade networks that required constant currency conversions, loan tracking, and interest calculations, the Babylonians basically created advanced computational devices out of clay tablets. They weren't just counting anymore. They developed advanced multiplication and division tables, reciprocal tables, and even solved quadratic and cubic equations. They were literally filling out complex algebra worksheets on clay tablets to speed through their commercial transactions. It's mind-blowing. And And this really highlights the incredibly advanced level of Babylonian geometry. They derived mathematical formulas for things like calculating the chord of a circle. They were mapping out complex geometry millennia before modern algebra was formalized. They definitely weren't just recording livestock at this point. They were doing high-level engineering math to manage a booming empire. Which perfectly sets up our final section, the legacy of ancient math. All this practical math, born in the sweat of Egyptian temple construction and the noise of Babylonian markets, laid the direct groundwork for everything that followed. Later Greek thinkers like Pythagoras took these highly practical economic tools and transformed them into abstract theoretical sciences. The Greeks inherited the hard-won data of the ancient scribes and started looking at geometry and numbers, not just to measure fields or calculate grain taxes, but to actually understand the fundamental laws of the physical universe. So the crucial point to take away from this entire explainer is this. Human civilization and scientific thought didn't just progress because some solitary genius was daydreaming in a vacuum. It progressed out of absolute urgent necessity. We learned to write, calculate, and engineer because we desperately needed to survive, trade, and build our societies. And the craziest part? The impact of this ancient administrative work is still with us today, every single second. The 4,000-year-old Babylonian Base 60 system was so incredibly effective and so brilliantly designed for dividing fractions that it outlived the fall of their entire empire. Which perfectly explains why today, thousands of years later, we still divide our hours into 60 minutes, our minutes into 60 seconds, and our circles into 360 degrees. It is a direct, unbroken echo of ancient accountants just doing their daily work. So I want to leave you with this final, provocative thought. Have you looked at your watch lately and realized you are effectively wearing a 4,000-year-old Babylonian tax collection tool right on your wrist? It's absolutely amazing how the mundane administrative chores of the ancient past built the very scientific foundation of our present reality. I leave you with that thought. Until next time, keep questioning the everyday world around you. All right, let's dive right into this explainer. We usually picture science happening in these sterile, super high-tech modern labs, right? But based on Dr. Abdel Azim Anis's incredible book, Science and Civilization, we're going to see how the real foundations of human knowledge were actually forged way back in the mud of ancient river valleys in Egypt and Babylon. And it wasn't out of simple curiosity. No, it was born out of absolute life-or-death necessity. I mean, think about it. Before we had modern apps or digital calendars or, hospitals, our ancestors faced some seriously monumental struggles. How do you feed a massive growing population? What do you do when the river that waters literally all your crops just unpredictably floods? Or how do you treat the terrible injuries people got while building the ancient world's greatest monuments? It was actually these incredibly practical, immediate problems that forced abstract ideas to become life-saving solutions. So, here's our roadmap for today's explainer. 1. Necessity is the mother of invention. 2. Reading the stars. 3. Solar and lunar calendars. 4. Medicine between magic and science. And finally, 5. The first surgical document. Let's start with Section 1. Necessity is the mother of invention. So as we see here, science definitely didn't emerge in a vacuum. It really came from the dirt, the water, and the brutal daily grind of survival. Organizing agriculture around violent, totally unpredictable river floods was literally a matter of life and death. And as these societies grew, they needed this enormous surplus of food to support the kings, the nobles, and the massive labor forces building these giant monuments. To manage all of that, society required unprecedented organization. You couldn't just guess when to plant crops anymore. The sheer scale of civilization demanded exact measurements, advanced planning, and just a really deep understanding of nature's cycles. Moving on to Section 2, reading the stars. To conquer the absolute chaos of nature, early humans had to look up. They had to turn the sky into a giant clock. You see, the Earth itself just didn't give them enough warning for the changing of the seasons, so the priests and scholars cast their eyes upwards. And based on our source material, Science and Civilization, the Egyptians made a totally brilliant observation to predict the crucial Nile flood. Because remember, the entire Egyptian economy, their very existence, depended entirely on the Nile. If it flooded too early or too late or didn't flood enough, famine. Famine would sweep the land. So the stakes, they literally could not have been higher. Well, they noticed something amazing. A specific star.
The star Sirius, which is known as Al-Shira in Arabic, appeared on the horizon exactly at sunrise, right before that life-giving Nile flood began. This event, the heliacal rising of Sirius, became their ultimate cosmic signal. The priests basically realized that the sky wasn't just a canvas for myths, right? It was a predictable, readable map. By meticulously tracking Sirius, they could warn the farmers, organize the planting seasons, and literally ensure the survival of their entire civilization. So this wasn't just casual stargazing. This was the actual birth of astronomy out of sheer agricultural necessity.
Which brings us to Section 3, Solar and Lunar Calendars.
So this single astronomical observation led to some massive innovations in timekeeping, and it varied super dramatically depending on where you lived, because once you realize the stars repeat their patterns, you can build a whole system around it. The contrast between two of the great ancient powers is actually pretty stark. Egypt established a solar calendar tied to the sun and the star Sirius. They created a 365-day year, divided into 12 months of 30 days, plus 5 complementary days right at the end. That is remarkably close to our modern calendar. Meanwhile, over in Babylon, they relied on a 354-day lunar calendar. But here's the catch. Because a lunar year falls out of sync with the solar seasons incredibly fast, Babylon needed a totally different approach to fix it. King Hammurabi and the other rulers had to rely on reports from officials tracking the new moon, and they would literally issue royal decrees to arbitrarily just shove a 13th month into the calendar just to keep their farming seasons aligned. Crazy, right?
But, even the Egyptian system wasn't perfect. Because their 365-day calendar missed a quarter day each year, which is what we fix with leap years today, the calendar slowly drifted out of sync with the actual seasons. Imagine celebrating midsummer festivals in the dead of winter. Over generations, the seasons shifted entirely. And that led to this incredibly relatable, honestly slightly hilarious complaint from an ancient 19th dynasty student who was literally begging the gods to save him from a year where winter had completely swapped places with summer.
And here's a wild number for you. It took exactly 1,460 years. That span is known as the Sothic cycle, or the Great Year. That's how long it took for their unadjusted calendar to naturally sync back up with the actual astronomical seasons. 1,460 years. Just think about the dedication of those Egyptian record keepers. They tracked this tiny discrepancy over thousands of years, passing data down through generations and generations of scribes. It really proves just an incredible commitment to long-term observation.
All right, let's shift gears to Section 4, Medicine between Magic and Science. Now we're pivoting from solving the mysteries of the sky clock straight into the mysteries of the human body. Let's look at how ancient magic was actually the true predecessor to science. See, in the ancient mind, an illness wasn't caused by germs. It was caused by an evil spirit moving in and taking up residence inside a person's body. So how do you cure the patient? Simple. You have to make the body a totally uninhabitable place for that spirit. And this logic led to the use of incredibly foul-tasting, repulsive potions. Now, sure, it sounds like pure magic to us today, but for them, it was a perfectly logical methodology based on their understanding of the world. They were using cause and effect. They just had the wrong initial cause.
And that leads us to our final part, Section 5, the first surgical document. So, the treatment of physical trauma, like from construction accidents and war, that forced a massive separation between magical rituals and observable science. Think about it. When a worker on a pyramid suffers a compound fracture or a soldier gets struck in the head with a mace, you can clearly see the cause of the ailment. It's not some hidden, sneaky spirit. It's a giant rock or a weapon. And this brings us to a really revolutionary breakthrough from ancient Egypt, the Edwin Smith Papyrus. Dating back to somewhere between 2000 and 1500 BC, though it's possibly copying text from as early as 2500 BC, this papyrus is widely considered the world's very first true scientific surgical document. It is a stunning departure from potions and spells. This text focuses almost entirely on observable physical realities. The papyrus lays out a strict, incredibly pioneering scientific method that is completely free of magic. It's an objective approach to healthcare that, honestly, we still use today. First, the physician conducts a physical examination. Second, they provide a diagnosis, and they explicitly classify whether the condition is treatable or untreatable. And third, they prescribe a direct physical treatment. There are zero incantations here. This is pure empirical observation in action. This document meticulously detailed exactly 48 distinct medical cases. It started from the head and moved downwards, and it included incredibly complex injuries like skull fractures and severe brain trauma. But what is truly amazing here is their intellectual humility. By categorizing certain injuries as an ailment not to be treated, they proved that they completely understood the absolute limits of their capabilities. They weren't out there promising magical cures, right? They were treating medicine as a strict, rigorous science, carefully documenting their failures and their successes so they could pass that knowledge down to the next generation of surgeons. So as you think about how absolute necessity birthed the incredible fields of astronomy and medicine right out of ancient magic and survival, ask yourself this: what current beliefs or practices in our modern world might actually be the stepping stones for tomorrow's great scientific leaps? What are we doing today that future generations will look back on as the humble, rudimentary beginnings of an entirely new understanding of the universe? Thank you so much for joining me for this explainer, and keep questioning the world around you.
Welcome to The Explainer. I am absolutely thrilled to have you here today because we are setting off on a grand, sweeping journey right back to the very dawn of human civilization. We're going to explore a time of monumental firsts: the first cities, the first writing, the first truly awe-inspiring engineering projects. But, as we'll see, the exact same things that allowed these ancient empires to rise up, well, they actually planted the seeds for their own devastating collapse.
So let's dive right into this central mystery. It's kind of this fascinating paradox, right? How did the brilliant minds of the ancient river valleys, societies that literally reshaped the earth and charted the stars, somehow engineer their own downfall? I mean, they hit these unprecedented technological peaks, yet those very same structures led to a completely tragic, devastating collapse. It's a story of remarkable innovation followed by a fatal dose of hubris. And honestly, there's just so much we can learn from it today.
Okay, here's our roadmap for today's journey. First, the Bronze Age boom. Second, engineering ancient marvels. Third, the social divide. Fourth, slavery and stagnation. And finally, the barbarian collapse. Let's get right into it.
Section 1. The Bronze Age Boom, a surge of survival. You know, early science wasn't just born in a vacuum. It was born out of absolute life-or-death necessity, a real surge of survival. Our explainer today is grounded in this brilliant historical analysis from the book Science and Civilization by Dr. Abd al-Azim Anis. What's so fantastic about this comprehensive study is how it connects all the dots between a society's economic needs, its social structure, and its scientific breakthroughs. Dr. Anis masterfully shows us how science and society shape each other, especially in the ancient river valleys of Egypt, Iraq, and India. Looking at the big picture of human progress, for thousands of years during the Old Stone Age, humans were basically just surviving, right? Gathering and hunting. Then, the New Stone Age brought us early agriculture. But around 3000 BC, boom, we hit the Bronze Age, and this represents human history's very first industrial revolution. Suddenly, we've got complex irrigation, massive surplus food, and the birth of the first true cities. And with those cities came entirely new, incredibly complex problems that demanded real scientific solutions.
So, the crucial takeaway here is that abstract science had highly practical, muddy boots roots. Take mathematics, for example. Priests in early temples were suddenly receiving vast grain surpluses and herds of cattle as offerings. Counting on your fingers or making little notches on a stick just wasn't going to cut it anymore. The sheer volume of this surplus birthed written symbols and fractions, literally the dawn of mathematics. Meanwhile, farmers desperately needed to predict the deadly yet totally life-giving river floods. Over in Egypt, they noticed the star Sirius always appeared right before the Nile flooded. That desperate need for agricultural timing? That birthed astronomy and the 365-day solar calendar. Necessity truly was the mother of invention here.
Moving to Section 2, Engineering Ancient Marvels, Mastering the Elements.
With early scientific breakthroughs in math and astronomy locked in, humans started manipulating their environment on a scale that honestly is still awe-inspiring today. Just look at this incredible feat from early Egypt. According to historical records noted by Herodotus and highlighted in our source material, King Menes literally moved a river to unite Egypt. It's like watching an ancient mega-engineering documentary. Step 1, he builds these colossal dams to block the old path of the mighty Nile. Step 2, he actually digs an entirely new channel for the river to flow through. And Step 3, on the freshly dried and reclaimed land, he builds the legendary capital city of Memphis. The level of precision, the sheer confidence required to pull this off in the ancient world, it is just staggering.
And that momentum of Bronze Age innovation, it just exploded across Egypt and Mesopotamia. Let's rapid fire some of these marvels because they are wild. King Snefru built a huge fleet of 60 seagoing ships to navigate the Red and Mediterranean seas. Over in Sumeria, they invented the wheeled cart, completely revolutionizing land transport forever. Back in Egypt, Amenemhat III constructed this enormous reservoir in Fayum to catch raging floodwaters and then slowly release them over 6 months for irrigation. And hey, let's not forget the sail. This was the very first time humanity harnessed a natural power other than human or animal muscle. It was an absolute golden age of practical engineering.
But this brilliantly illustrates the next big shift. Think about the sheer scale of ancient monumental architecture, like the immense temples and pyramids. You don't build these by having a few villagers casually working on the weekends. No way. Building these marvels required an unprecedented level of large-scale central organization. It required the birth of the state. But, as Dr. Anis points out in the text, in organizing hundreds of thousands of people to build these structures, society inadvertently planted the seeds of a deep, tragic inequality.
Which brings us to Section 3, the social divide, the tragic flaw.
Now we have to pivot in our narrative arc from the rise to the hubris. This vast agricultural surplus and the need for central organization completely fractured society into distinct, permanent classes. Let's break this divide down. On one side, you've got the ruling class, the kings, the priests, the scribes. Now, because they lived off the surplus produced by others, they had the free time to study theoretical science, astronomy, and math, but they were completely isolated from physical labor. Then, on the other side, you've got the working class, the farmers, the artisans, the slaves. They performed literally all the manual labor and knew the practical properties of materials, but they were entirely barred from learning to write or recording their scientific observations. The vital link between theoretical thought and practical technology was completely severed.
Section 4. Slavery and stagnation. Progress grinds to a halt.
As these empires grew through conquest, the elite became increasingly reliant on a constant influx of enslaved prisoners of war, and this reliance would prove absolutely fatal to innovation. I love this anecdote from the source material because it perfectly captures the hubris of the era. A student once asked the great mathematician Euclid what the practical value of learning geometry actually was. Euclid was deeply offended that his pure, noble science would be associated with something as lowly as practical work. So he called to his servant and said, "Give him 3 coins, since he must make a profit from what he learns." That was the mindset. The ancient elite had utter contempt for practical application and getting their hands dirty.
So think about this. How many new labor-saving inventions does a society pursue when it has an endless, abundant supply of forced slave labor? 0. Literally 0. If you can just throw thousands of enslaved humans at a problem, whether it's milling grain or moving massive stones, there is absolutely no economic incentive for the brilliant minds of the era to invent machines like water mills or complex gears to do the work. Why invent a machine when you have free labor?
And here's the devastating result. Science without application becomes a stagnant ritual. Because the intellectuals flat out refused to test their theories in the mud and the dirt, science devolved. It just stopped moving forward. Astronomy turned into astrology. Medicine stagnated completely because the elite physicians wouldn't perform surgery. They considered that lowly butcher's work. Innovation ground to a total halt, and society became frozen in these repetitive, sterile traditions, totally devoid of practical progress.
And that leads to our final chapter, Section 5, the barbarian collapse, the inevitable fall.
A society just cannot remain frozen forever. This internal rot made these great ancient civilizations incredibly vulnerable to external threats. Let's look at the multi-step autopsy of their collapse. First, the ruling elite becomes completely isolated, living in absolute luxury but totally disconnected from reality. Second, the working masses and slaves are utterly impoverished and frankly have zero loyalty to the empire. Third, because of slavery and this intense elitism, technological innovation flatlines. And fourth, this is the kicker right here. The nomadic tribes living on the fringes of these empires, the people the elites called barbarians, begin to adopt the center's weapons, tools, and technology. The empires had essentially hollowed themselves out from the inside.
Which brings us to a dramatic climax. Those nomadic tribes out on the fringes, they weren't stagnant at all. They were incredibly adaptable. They took the center's technology, like the wheeled cart, and they weaponized it, creating the lightweight horse-drawn war chariot. Later, they would be the ones to adapt iron, while the old empires were still stubbornly clinging to bronze. Armed with the center's own adopted tech, these highly mobile, motivated fringe groups easily swept in and toppled the stagnant, rotting empires of the ancient river valleys. The fringes conquered the center using the center's own tools.
It's such an incredible, cyclical story of history, isn't it? They rose up through brilliant, practical problem solving, but they fell because their social structure caused them to look down on the very labor that built them in the first place. Which leaves us with this final thought to ponder today. If a society stops valuing the hands that build it and completely severs that tie between theory and practice, can its progress ever truly survive? Thank you so much for joining me on this explainer. I really hope you found this dive into the source material as fascinating as I did. Keep learning, keep asking those big questions, and we will catch you next time.